Hi there, well it's been a while since I posted my last video for the Post Twin. I've been tied up on all sorts of DIY stuff, and one thing leads to another, and I've been involved in sort of plumbing and a bit of electrical work and what have you. And I also got a little bit sidetracked with software defined radio, and I bought an SDR receiver to plug into the laptop. And a few months ago there was a Spitfire taking off and landing from a local airfield not too far away from me at all, and he was doing trips, 20-minute trips for £3,000 each. Needless to say, I didn't go on one, but it got me interested in watching planes take off and land at that particular airstrip. And using Flight Radar 24 and ADSB Exchange, there was no coverage around here, so I decided to make my own ADSB Exchange receiver. So now, well, that's using a Raspberry Pi, and I've put a little aerial up, and now I can see in detail all the aircraft taking off and landing at that particular airfield. And I can also see aircraft about 120 mile away if they're at a decent height. So that is now contributing to ADSB Exchange, so anybody in the world now can see in detail aeroplanes taking off and landing at that particular airstrip. And then it also got me thinking about, well, wouldn't it be great to be able to download weather satellite images from satellites that go across, not geostationary, but there's NOAA 19 and a 15 and a 16 maybe, 3 satellites that pass sort of during certain times of the day, well, varying times of the day, and you get a glimpse of them round about 11 minutes each time on a good day. And I managed to download some weather satellite pictures, so I'm pretty chuffed with that. But anyway, having got SDR radio out of my system now, I'm starting to look at the Upshur Post Twin again. And in this video, hopefully, I'll be able to machine the cylinder heads. Now, when I started looking at the drawings for these cylinder heads, I realised that the sort of margins are quite fine. And I thought what I needed to do first of all is to decide on the spark plug I'm going to use. And I was hoping to use a Rimfire VR2L, which, going by the drawings, would be a good fit. But I went to my usual supplier, Minimag, and they were out of stock. And I then thought, well, maybe I'll just go for a normal reach and change the drawing slightly. They're out of stock on those as well. And then I went for V2. They're out of stock of those as well. So the only one they had in stock was a V3, which is quite sort of like short thread length, and this is one of them. So I bought 2 of these, £29 each, and having got them, I thought that this thread was far too sort of short. There's probably 4 threads in view, and with it being aluminium, I suppose there's certainly a higher risk of sort of stripping the threads. So I wasn't happy. So I did a bit more research, and I came across these RCXL Iridium spark plugs, which on Just Engine's website, the information was a bit thin on the ground, but they didn't have any in stock anyway. Now I've just checked the stock levels again, and Minimag don't have any Rimfires at all. I think there must be a worldwide shortage of these Rimfires, and Just Engines have just got in some more stock of these, but the price has increased to over 21 quid. But anyway, at the time, with it being a few months ago, I decided to look at some of these Chinese websites, and on AliExpress I came across these RCXL Iridium spark plugs, which have got similar sort of specifications really to the Rimfire
VR2L, and these would be a decent fit into the heads without changing any of the sort of dimensions. So I decided to buy a couple of those, and these arrived, and they look okay, and decent sort of thread length. So I'm quite happy with those. So that's what I'm going to go with. Now, if anybody does want a couple of V3s, rimfires, you can buy a couple off me if you want. If you're in the UK, we can call it 20 quid each, including delivery. But there you go. Oh, and one other thing I needed to consider was the box spanner. And again, things are very, very tight. So I decided to turn this box spanner down. So that is just, I think, under 11 millimeters. I might be wrong there. But that's as close I can get. So I might have to change the specification of the drawing to enable a bit of clearance for that. But like I say, everything's okay. So as most of this is drilling and the pressure is downwards, I've used this 4-jaw chuck just to hold the piece and put it in the vise. And I've used coaxial indicator to find the centre. Then on the DRO, I've used the circle function, or the bolt circle function, and set the diameter to be 1.156 of an inch with 4 holes. So I'm going to centre drill first of all, starting at this position here, 90 degrees from the top. Okay, so what I'm going to do now is drill right through using an 1/8 of an inch drill bit, but I'll do that bit off camera. And this is a 5mm 2-flute end mill, and I'm going to go to a depth of 0.312. Now this is a bit of Mission Impossible here, and I've made life a little bit more complicated for myself as well. So with me sort of drilling in these positions here, rather than sort of across this way, there's a requirement to drill a hole here and tap it 0.375 of an inch from the centre point. From that plane there. So I've calculated using sine and cosine that the x and y coordinates of this point here should be 0.26516, and that's what I've set the DRO to, and I've just used a little centre drill there. Now the difficult bit here is the drawing states that you need to drill and tap 5B40 to a depth of 0.125 of an inch, which is pretty much impossible for me. And it's 0.125 of an inch because you shouldn't go through to where the spark plug is, because the spark plug's going to be, the housing is going to be drilled through there. But what I'm going to do is I'm going to drill through into where that cavity is going to be for the spark plug, and when I come round to putting everything together, this is going to hold a post for the rocker post, or a bolt for the rocker post. So what I'm going to do is I'm going to put a stud in there, and I'm going to JB weld it in. So fingers crossed it'll be okay. But I guess we'll see. So I'm going to drill to a depth of not 0.125 but 0.325. So that'll allow me now to tap this reasonably okay. So I'll get plenty of thread on it because I've gone beyond the 0.125 of an inch. But I'll tap it off camera. Okay, so now to drill the holes for the spark plug. And what I've done is I've put some bolts through here and rested the piece on the heads on the vise. So that's got it level. And then I've just used this to get on centre. What I'll do now is I'll use a little wiggler to find the centre point. Once I've found the centre point and centre drilled, I'll get back to you. Okay, so this is a 5.5mm drill bit and we're going to go 0.55 of an inch deep. So this is a 3/8 of an inch 2-flute end mill, and this is going to go to a depth of 1/4 of an inch, and this will give a nice sort of flat surface for the spark plug to mate up with. And this is an 11mm 2-flute end mill, going down just 0.1 of an inch just to give clearance for the box spanner. So this is a 1/4x32 tap, and due to the amount of material there is, I'll probably only get 2 or 3 threads out of it. I think I'll have to revisit this once I've opened up the other side, if that sort of makes sense. Struggling doing that. I think I'll have to revisit the tapping once I've opened up this other side. We can see what we're playing with then. So I've switched it round in the 4-jaw chuck. And I've put these bolts in, and against the head I've rested this ruler, and then I've eyeballed it to be sort of parallel with the top edge of the vise, so that looks good. So what I need to do now is to find this centre. Probably can't use a coaxial indicator because I've got a hole there now, so I think I'll use an edge finder. But I'll do that off camera and I'll get back to you once I've got the centre. Well, I found the centre, and then I've put this 3/16 of a diameter 2-flute end mill in there. Move the Y axis that way 0.218 of an inch, And now I need to drill 0.35 of an inch. Okay, so having milled that hole now, I can see where the tip will come down to. So it gives me a better idea in terms of what's left. So I'll just tap it, but I'll do that bit off camera because I need to get in close. I think I got a result there. Very fine margins, these. So that's the spark plug with the bronze washer on it. If I take the bronze washer off and put it in, the tip of the spark plug comes down further, so that proves to me that the washer's sealing. And just perfect for that box spanner. So now I need to make the holes for the valve guides, and I've made this fixture. Nothing special really. Piece of aluminium. I've tapped some holes here to hold the head on, and just cut this recess in here to allow the drill bit to go through, and the reamer as well. So go over to the mill and get it set up. So I've put the fixture between some V-blocks in the vise, and I centred, and I've moved the DRO x-axis by 0.187 of an inch to the right and to the left, and I've centre drilled. Now what I need to do is to drill through with a 5.5mm drill bit. And I'll do the other one off camera. And now to ream through with a 7/32 of an inch reamer. And now I'm in unknown territory, because the valves I've made in the past have used their own valve cages. So that actually meant that cutting the valve seats for the valve cages I did on the lathe, and I did it while making the valves. However, the valve seats on these heads are actually cut into the aluminium, and I suppose I might be tempted to try and cut these now using a 90-degree cutter. But you only need to be a thou off to find that once you make the actual valve guide, which will sit in there further up, that the actual valve that you make won't sit in it properly. So I'm going to hold off that until I've actually made the valve guides. Once I've made the valve guides, I can then try and make the seat using a tool that George Britnell has designed. So I'll have to make that tool, and maybe use a bit of my Quorn machinery as well. So what I'm going to do now is to drill the portholes in each side. So I've switched the fixture around and put it in this vise, and put a square on here just to make sure that it's at the right angle, which it is. So what I'll do now is I'll use an edge finder
and find the centre, then find this edge here, and then move in half the width of the head, and then I'll drill and ream. I think it's 1/4 of an inch, but I'll do all that off camera. Well, that's most of the work done. The only outstanding issue, or work to be done, are the fins. Well, I thought the fins had been absolute doddle, but looking at the drawing, some of the fins are sort of dimensioned on a radius, and I've been trying to work out how to cut it on the lathe or the milling machine. I just can't work it out. So I've decided that instead of cutting a radius, I'm going to cut down in increments. I'll show you later the calculations I'm using, but I'll be moving across here at 30 thou increments. This is 2.5mm drill bit, or two flute end mill, and that'll give me a width of about 98 thou, and the actual width of the fins is going to be 60 thou. So that's the plan. So the idea is I move it along 30 thou, drill a bit deeper, another 30 thou, drill a bit more deeper, and till I get roughly the right profile. But I'll do that off camera, and then I'll get back to you once I've completed the job. These bottom fins are quite straightforward. It's just a matter of plunge cutting to 0.312 of an inch, moving the table that way a little bit, doing it again, repeating all the way, and then coming back again and joining the holes up, and then eventually just running the drill bit or the 2 flute end mill across. Well, having done all the plunge cuts, it's just now a matter of running the drill bit through. I'm going to go in 100 thou increments at a time. So for these slots here, it's sort of quite a sort of steep radius, if you can call it that. And I've calculated that I need to start on this one, 0.3 from the centre on the x-axis, and I'm going to be cutting in 30 thou increments. My first cut is going to be 57 thou. So now I'm going to move 30 thou. Wrong way. And my next cut is going to be 101 thou. another 30 thou. And my next cut is going to be 134 thou. So I'm going to carry on like this until I've completed all the cuts, and that's sort of like a list of what my cuts should be. I'll show you that once I've completed all of the work. It's a little bit difficult to see in this light, but it seems to have turned out okay. So I need to do another one there, and 2 on the other side, and then a final one. But that'll just be a straight cut, very shallow. I'll do all those off camera. Well, they didn't turn out too bad. I think at some point I might use a bit of wet and dry just to get rid of some of these machining marks. This is one of the sort of like large radiuses. So this is based upon the centre out here somewhere, and that's a shallow one, and that's a centre that's a bit closer, I think. I tried replicating the drawing in Fusion 360, because I thought actually if I could get the drawing into Fusion 360 I could machine these on my CNC little milling machine, and that would have been ideal really, but I just couldn't get my head around how to replicate these radiuses with the centre points being out here, and I was creating planes and all sorts of things, but I just couldn't master it. But I suppose at the end of the day it didn't turn out too bad. I think also if you've got a vertical slide for your lathe, that might work. I've not got one, and I did actually look on the internet to see if I could get a vertical slide for this SC4 lathe, but I couldn't find one anywhere. So you know, it didn't turn out too bad, and these are the calculations I made. This is for the deeper radius. I'll make these available on the internet, download from the YouTube page, and the starting point at 0.3 of an inch from the centre line on the x-axis, and then these are the depths that you cut to as you progress along, 30 thou increments at the top, like that. And there's a similar one for the shallower groove. So that's for that groove there, and that was starting at 0.389 here. Actually, the centre one I actually like to start at 0.406 because there was a clash with the bolt head. Yeah, sort of got there in the end. Not much more to say really, I don't think. Oh, there's some relief to be made for the push rods here at some point. I'll do that closer to assembly, and I think this groove here should have been 60 thou deep, and I made it 50 thou because I opened mine up a bit for the spark plug, a little bit more than the drawing. But apart from that, it seems to have turned out alright. Well, I never thought it'd take me about 4 days to make those 2 heads. Probably took me 1.5 to 2 days just to cut the sort of fins, but I got there in the end. And I think my next video will be to make the valves. So that's going to be a bit of a bottle job because I'm going to have to cut the valve seats in these heads. So one thing I don't want to do is to mess that up. I think I mentioned earlier I'm going to try and make a tool that George Britnell designed. He's got a design that's available on the internet. So I'll have a go at making that. The idea being that make the guides, press the guides in, and then cut the seats, which is the right way to do it if you're not using valve gauges. But anyway, I hope you enjoyed the video, and I hope to see you later.